Welcome to This Explainer. You know that classic image of the wild, the ripped, muscular predator just effortlessly overpowering the weaker, defenseless plant eater? We've all seen it. But today, we're diving deep into the high-stakes, visceral world of predators and prey to look at the actual hard biological data. Are hunters really stronger than the hunted? Or have we completely misunderstood this entire evolutionary arms race? I mean, it's a super common assumption, right? It's perfectly captured by this dramatic quote from the Nature Institute describing a lion. They talk about how its concentrated tonicity erupts into the sheer might of its sinewy being, and that it feeds ravenously upon the element in which it lives, muscle. That paints a picture of a creature that is just built out of unparalleled physical superiority. We just naturally assume carnivores overpower prey with sheer brute muscle. But actually, the science tells a much, much more fascinating story. Let's start with section 1, jaws, levers, and bite force. To really debunk this myth, we have to look at the primary weapons these animals use to survive, their jaws. Because think about it, if a predator is just inherently stronger, their bite has to be the result of massive, overpowering muscles, right? Well, not exactly. A carnivore's jaw isn't necessarily stronger in terms of raw muscle fiber. It's a highly specialized lever built specifically for shearing meat. Notice the longer coronoid process and how the jaw joint sits perfectly level with the tooth row? That specific alignment lets the temporalis muscle deliver a massive, direct hit of force for breaking bone. Meanwhile, the herbivore's jaw has a completely different day job. They have a taller mandible arm that pushes the joint way up above the teeth. That engages the masseter muscle, which is absolutely perfect for the endless, repetitive grinding of really tough plants. So the secret here isn't brute power, it's physics. It all comes down to the in lever. That's just the distance from where the muscle attaches right down to the actual jaw joint, or fulcrum. By tweaking this biological lever, animals totally change their mechanical advantage. Carnivores didn't evolve universally stronger muscles across the board. They just evolved bone structures that maximize bite force for that one explosive killing bite. Herbivores, on the other hand, evolved levers built for endurance chewing so they don't tear a muscle just eating dinner. Moving on to section 2, the heavy burden of digestion. Strength and speed in the wilds aren't just about the muscles you pack. They are heavily dictated by the weight you're forced to carry around. We often completely forget that diet fundamentally changes an animal's internal architecture. Carnivores consume meat, which is highly digestible. Because of that, they've evolved relatively simple, short digestive tracts. Herbivores are eating fibrous plant material that is incredibly tough to break down. To survive, they are literally weighed down by their own food, forced to carry complex, bulky digestive systems and massive fermentation vats just to process their daily meals. To put that into perspective, when researchers looked at 25 different species of carnivores, they found a staggering statistic. A carnivore's dry matter gut capacity is only 29% of a herbivore's. 29%! Imagine trying to run a sprint, but your opponent is forced to wear a backpack that's 3 times heavier than yours, completely stuffed with digesting food. That is the daily physical reality for prey animals. And that completely shifts how we view the predator's advantage. Because they take in less dry matter and process it way faster, they carry significantly less inert baggage in their stomachs. This makes them substantially lighter, far more agile, and so much faster on their feet. Their advantage isn't that they have inherently stronger leg muscles. It's that they are traveling incredibly light, which makes them functionally way more explosive in a chase. Which brings us to section 3, the muscle power plot twist. Okay, so if a lighter gut gives predators an agility advantage, do they also back that up with superior, high-powered muscle tissue? You might automatically assume an apex predator like a cheetah or a greyhound just naturally generates more cellular muscle power than the prey they hunt, like a rabbit or a hare. After all, they're famous for these explosive high-speed pursuits, right? But when scientists actually measured this, is that what they found? Surprisingly, the answer is a definitive no. Researchers tracked cheetahs, greyhounds, hares, and rabbits using high-tech GPS and IMU wildlife collars to calculate their actual muscle power output based on velocity and acceleration. And the results? The acceleration performance and muscle power output between the predators and the prey were remarkably similar. It is virtually a dead heat. A cheetah's muscles aren't magically producing more power per unit than a hare's. What this really means is that hunt outcomes aren't decided by some massive gap in raw muscular strength. The performance arms race is constrained by entirely different things. It comes down to highly specialized skills. We're talking about musculoskeletal gearing, the friction and grip of their paws on the dirt, how quickly they can initiate a sharp turn, high-speed maneuvering, and sensory detection. It's a game of ultimate biomechanical skill and finesse, not just a brute force arm wrestling match. In fact, comprehensive studies on muscle mass scaling confirm this across the board. When you account for total muscle mass, the internal force-generating architecture of these animals follows a single common scaling pattern. Whether you're looking at reptiles, mammals, or bipedal birds, once you factor in how much muscle an animal actually invests in its limbs, the force-generating capacity scales totally predictably. Predators just don't pack secret magical strength into a pound of muscle. Tissue is tissue, and physics is physics. Which leads us to Section 4. Size rules the animal kingdom. If muscle tissue quality is generally a tie, and jaw leverage just changes the angle of attack, what actually makes one animal stronger than another? Well, a massive natural history museum study of 161 different species completely shatters the predator's strength myth once and for all. When plotting bite force against head size and overall body length, the data proves that bite force scales linearly with size. This is entirely regardless of whether the animal is a carnivore, an omnivore, or a herbivore. If you have a bigger head, you have bigger jaw muscles, and therefore, you bite harder. It is literally that simple.
So here is the ultimate twist of this explainer. Plant eaters often have much stronger bite forces than meat eaters, simply because their diets require larger overall bodies. Remember those massive digestive tracts we talked about? Herbivores need bigger bodies just to house them. And because their bodies and heads are larger, their jaw muscles have a much greater cross-sectional area, allowing them to generate incredible force. A large herbivore will easily outbite a smaller carnivore, purely based on the physics of size.
The idea of the inherently overpowering predator is a total myth. Their success relies on specialized bone levers, an empty stomach that keeps them light on their toes, and incredible maneuverability, not superior muscle tissue. So, if the predator's overwhelming strength is mostly an illusion created by size, leverage, and gut weight, what other invisible biological secrets are hiding right in front of us in the wild? Keep that in mind the next time you watch a nature documentary, and always keep questioning what you think you know.